Okay, guys, hello. How are you doing? Do you like the conference so far? Cool. Okay, so my name is Andrey, and I'm going to talk about DevOps, basically, and how enterprises are treating that, and what are the challenges, probably. And okay, just a few words about me. I always like to position myself as a developer, and I always will be a developer. I like coding. But for the last couple of years, actually, well, not couple, actually, very 4 years, I do a lot with the operations part of IT business. So I help IT organizations not only to develop software, but also to maintain that and to maintain the operational part of that. You can see my connection details out there, so if you want to connect me later, talk to me later, you can either come after that session here or follow one of those. Okay, they say that in order for the presentation to be rememberable, you have to tell the story, and I'm going to tell the story. It's not a real story; it's a made-up story, but it's based on real experience that I accumulated when working with different clients. So imagine you have a nice traditional organization where things are split into departments when people are specializing in certain things, and that's not a bad thing per se. So that's how usually it's organized. So you have developers, you have QA people who do testing, you have IT operations, system administrators who actually support your systems, and you have managers all over the place. So imagine that, well, the story gonna be started from operations point of view. So imagine we have a system administrator, or his name is Jack, and let's say at some point his manager comes to him and says, yeah, okay, well, we need a couple of new servers, and that's to support our secret project, and we just need them quite soon. So Jack said, no problem, but that service that's what we do. We order new hardware, we set up the networking, we start working, and after a couple of days, one server is ready. After another couple of 5 days, another few servers are ready, and after a while, everything is ready. Then another requirement comes. Even though the project is secret, but developers are kind of already want to start working, and they need those servers, but they're not yet ready. But what happens is that Jack's job is being reprioritized, so he have to do something. At the same point, Jack has his own boss, and his own department has his own guidelines and rules for the work they do. So Jack's boss says, you know, you have to write documentation of what you did. Jack says, no problem. Well, that's what we do. We know how to write documentation. We know how to support servers. We know how to configure them. We know what to do, how to handle it over to the next department, like development or QA. So everything is okay, and we're cool. But in the meanwhile, there's a new requirement coming in. Again, through a secret channel, through some unusual way, and Jack's manager, one of Jack's manager, gives this to Jack and says it's important, it's platinum priority, so you have to do it now. But at that same time, developers who already wanted those servers, they start working on them, and Jack, while implementing this change request, is breaking the servers. He broke the servers, and developers can't deploy, so people are happy. And the next day, like at 3 a.m., Jack is happy. He fixed everything, but kind of documentation is already in an unusable state, but it works for developers, so at least they are happy. But it's getting even worse, because change requests, different level managers are sending new tasks to Jack, and well, he's happy to do that, but he's becoming overwhelmed. And the thing is that the environments, the infrastructure of the organization is not down, it's working, but it's actually worse than that. It's an unknown state. Documentation is unusable. Server configuration, application configuration is kind of unique for each server. And that, of course, that causes a lot of problems. That basically means that you have a chaos. Chaos in your infrastructure, chaos in your deployments, chaos in your organization as a result. But you know, life is going on, so we need to move things forward. And the secret project that developers were already working hard on, they produce a lot of code. They say, okay, now it's ready for testing. So it moves into QA. And now additional workflow that comes from another department, from QA, is now even more overwhelming the operations department. And sometimes people are producing a lot of noise by asking things that they don't even know what they mean. For example, like a QA developer can ask, can you increase the connection pool size because we have this problem? But the QA may not even know what a connection pool is. But he gives this task to a system administrator who needs to either reject it or kind of do something about it. So you get a lot of noise. And the more environments you have, the worse problem becomes. And of course, the documentation is already thrown away, and nobody cares about that. Everybody cares about supporting the environments and supporting things to be at least in somehow runnable state. And of course, at some point, the secret project that everybody was working on for a while, it needs to go live. And the way to handle this kind of situations in traditional organizations, the thing that happens is that you throw more people at that. Okay, you have many environments, you have many servers, you have many configuration options, you have many applications running on those environments, and you want them to be configured. So you just throw more people at that, and they struggle without much communication between each other, which doesn't make things much better. It eventually allows the project to run and probably even get some happy customers, but from inside, it doesn't look very good. So what happens in this kind of situations when you don't know what's going on with your deployment, when deployments are manual, or when server configuration is manual and unique per server, then it starts to fire. The emergencies happen all over the place, randomly or semi-randomly. And now everybody is focusing on production, not caring about any other environments where probably developers are still developing some code and testers are still testing some stuff. Everybody cares about production. Sorry. So, well, operations people, they're professionals. They of course they have something, and then that they reuse from one environment to another. So, do they have any kind of monitoring? Yes, we do have monitoring, but the problem is that the new application that was deployed onto production is kind of not monitored at all. So we monitor, let's say, CPU. We monitor memory. We want to monitor disk space. But we don't monitor, let's say, number of requests coming into application, or the size of connection pool that this application supports. So the dashboards that operations have do not show that the problem is there. But the problem is obvious because clients cannot use the system anymore because the connection pool is full. And the dashboard that operation people have doesn't show that. So the worst thing about that is that clients or managers who are being called by clients know about the problem earlier than operations guys. And, well, what can you say? Sorry. So is there any happy ending to this kind of situations? Probably. And just to know, guys, did you ever see this kind of project in your life? Anyone? Okay, that's quite a lot. I mean, like half of the people. So, where's the problem? Where's the problem of these things happening? And as it appears, as everything, in fact, in software development, is all the problems come from lack of communication or incorrect communication. And it appears that developers and operations, they don't like each other, well, usually, or they try to avoid each other. So the communication between two departments happens either through management or very occasionally. And the thing is that information comes from development. Let's say, this is an application, this is how it works. this is maybe some requirements for performance settings. Go do it. Go deploy to production. And operations people silently do that, but they never or rarely give feedback back to developers. Like, what the heck, guys, are you doing? This is the wrong architecture. This doesn't deploy to production. This is the wrong naming for the settings. This information, it not always reach back to developers, and they don't really feel the pain that the operations people feel when they have to support the production application. And the thing is that those two departments or those two communities of people, they are quite separated. And it appears that operations department usually is even more segmented than the development. Because developers, most of them are quite communicative. They know how to work with each other. They usually use agile techniques to develop products. Maybe some of them still use waterfall, but operations people, they like to specialize. So whether they do monitoring, whether they do network, whether they do only the server setup or infrastructure setup, they're even more segmented in that sense. And it usually like appears that those guys talk together like two different countries, like through foreign ministers, and exchange information on absolutely different languages. And in fact, operations and developers, they have two absolutely opposite goals, because developers, especially if they use agile techniques, they want to produce code, they want to produce new changes, new systems, and they want to do it fast and quick in an agile way. On the other hand, operations who support production systems, they like stability. And there's always a fight between stability and agility of the software delivery process that actually happens between devs and ops. And if application is designed in a way that it's hard to deploy, and its configuration is hard to maintain, and not easy to understand what's going on at all with the application, then it leads to fear of deploy. So from one side, you have to deploy often, but because you're agile, but on the other side, you can't, because the whole process of deployment, of provisioning infrastructure is not automatic and is not reliable. And that's why people, both devs and ops, they tend to postpone the deployment to a longer term, but that actually doesn't solve the problem. It actually makes it worse, because the more you postpone the pain, the bigger it is in the end. So DevOps is basically something that allows both sides to be more agile than they are probably now. Another important thing about operations and about maintaining things in production constantly, and in not only production, like in other environments as well, is that if you have more or less constant change rate of code, of configuration, of infrastructure, but huge amount of that is either failing or is done in the wrong way, in an unauthorized way, like not using version control or doing things directly on the environment, then what it leads to is that the number of unplanned work, the amount of unplanned work that is laid on the table of operations or developers is increasing. And the risk is that you can actually have more work than you have time, which will eventually kill your organization. Another interesting aspect is that if you have a lot of unique configurations, and it doesn't matter what it is, like it's operating systems, it's different application containers, it's different versions of libraries, and if you have a lot of different, if the number of unique configurations is huge, then also the mastery of each of that configuration is going down, because you can't just focus on every one of them. You have to split your time, and then basically your mastery, your knowledge of each configuration is dropping. And with all that, also the change rate that the success rate that you can apply to those configurations is also dropping. And this obviously also leads to the amount of unplanned work being raised, which again can lead to a situation when you have more work than you have time. So DevOps is here to kind of solve the problem. And it's a nice term. It's a nice term, but and many people understand it differently. But like with anything in software development, DevOps is really about fixing communication. And in this case, it's about fixing communication, about information sharing between developers and operations. And as you see, this picture looks like they're playing on the same field like a football players. Sorry. So they have opposite goals, almost opposite, but they have to play together to actually achieve the same goal, that to make their business survive and be profitable. An important part of this picture as well, that the feedback loop should be both sides. So it should really be a loop, and things that are happening in production should go back to developers, and things that are happening in development should go forward to operations, and they have to share the information. And the shorter is the feedback loop for knowing these kind of things, the more effective you are, and the more deployments and the better infrastructure support you can do. And as already mentioned, like sharing information is important, and sharing responsibility between departments is as important as well. Because the main goal is to make your business happy, and you have to work together to actually make that happen. So the focus of DevOps is on automating tasks performed during build, QA, and deployment stage, and the risk of deployment errors is reduced drastically by having a strong automated testing suite, automated deployment workflow, and well-defined automated rollback process. And as a result, if you try to do changes to the environments, to the configurations, to the applications in the same way, in an automated way, and in a way that is defined by the process that you define for your application, then obviously the unplanned work should go down. Also, if you tend to reduce the number of unique configurations that you have, then obviously the mastery of each configuration will grow, and this will also raise the success rate of changes that you make. And again, this will influence the amount of unplanned work that you may have. And unplanned work that is something that may kill organizations easily. Because if you have too much and you don't have control of that's something that will eventually be painful for everybody. So, great. Now we heard about DevOps, and let's just do it. It will save us, hopefully. But, you know, as with many trendy keywords like DevOps, Agile, Scrum, whatnot, people tend to put too much expectations on them. And they just believe it's magic. But obviously it's not. And in fact, a lot of things depend on people themselves. And that's actually part of the reason DevOps doesn't have a proper definition, and DevOps doesn't have a manifesto like Agile does. And it will never have, because those who are kind of leading this community and movement, they don't want people to focus on the form, but actually more focus on the principles. And the principles are sharing responsibility, making your business win. That's the most important. And the thing is that, well, I guess most of people here are developers. I'm a developer myself. And I like tools, I like coding, I like using different new things, new libraries. And most of those, from a technical point of view, those who start with DevOps, they start with the tools. So did I. I also used different kind of tools for like Puppet, Gradle, Chef, Ansible, whatever. And yeah, that's all cool. That's really a cool stuff. But I actually, in one of my clients, I failed to make it further because I focused too much on the tools. But the most important part actually is not the tools, because it doesn't matter what you use. Could be anything. Could be, the most important part is the internal culture. It's important for Agile, it's important for DevOps, and because some of the people, maybe some of the top managers, they actually don't believe what you're doing, or they just, okay, just go do it. I don't care what you do. They don't support that on the top level. Then some of these toolings, they may just be a waste of time because nobody is reusing them, or nobody is fully understanding what's going on and why we do this like that and this like that. There's a good way. There's an acronym that I like a lot that defines what DevOps is, and it's called CAMS. Basically, it's four components. It's culture. So people are more important than processes, and software is made for people and by people. Of course, to save people's time and to improve the process, automation is very important. And then you also should measure everything that you can, basically, preferably in production, but also, you can measure a lot of things. And the more you measure, the more you know of how qualitative your software and whether you're going down, going up in certain metrics. And another part is sharing. So it's kind of part of the culture as well. You need to share information. Okay, and now I'll switch to the second part of my presentation, where I'll try to give some hints to developers and to operations of what can be improved in order to move to like DevOps way of doing things. Well, first of all, of course, people need to talk. Just go and find a friend, like someone in the operations department. Just try to talk to him about what is going on. Try to understand his problems, and try to talk more about it, because you will realize that if you're a developer and you never talk too much or never thought good things about operations guys, actually they are good guys. They are different sometimes, but they're good guys, and they actually also they try to do their job professionally. Share information and share everything, and I'll get back to that. So just some hints for developers. Well, as I already said, don't ignore operations, and the two interesting terms that I found out on the internet, that when developers tend to ignore the operational part of the application, they think that operations do not exist. So operations turn to be something that it's his job. He will do it, no problem. So it's called like shadow ops. Another one interesting is if developers try to do operations totally by themselves, it turns to be like dev oops, and that's where something happens as well. So don't ignore operational part, because probably it may seem easy, especially now when we have a lot of virtualization and pretty much everything has an API. So it seems like you can program anything, code everything, but still knowing the operational part of the business may not be your specialty, and you may not know a lot about it. The first thing that I guess all developers do, and this already was mentioned on some of the previous presentations, about 45 tips for developers, logging. Because logging is something that operations guys will probably, well, most likely will read. And they are your clients. They are clients with log information. Because they have to use it to resolve the problems. Or maybe you as well need to use it to resolve the problems. So if you don't pay attention to the login level, to the message you produce, to the frequency of logging that you do, then it may disturb a lot, and that may produce a lot of noise that will eventually will not allow you to find the problem early enough. And just some bad example of I found in my computer is Microsoft Exchange Server, but the log is pretty much unreadable, just a bunch of numbers. And I guess maybe it's fine for some analysis tool, but it's not fine for a human being. So login messages should kind of be at least readable by a human being, in my opinion. Another big part of configuration of application usually is its configuration, like configuration files like XML or JSON or YAML or whatever. And again, initially, maybe when you create your first code lines, your application is not configurable. It doesn't have anything. But then slowly it starts to get some configuration, like database connection details, like, I don't know, number of the level of discount you give to the client, the email addresses of technical persons, whatever. And somehow, at least in my experience, people tend to use pretty random names for configuration properties, and they do not structure them quite well. But again, this is something that is important for operations guys. They need to know what are the configuration properties for, what this configuration setting is meant for, and you should try to keep it backward compatible. You should give good default value to that, and as you do with code, with classes, with methods, configuration properties should have good naming as well. And just if you're a lucky owner of Windows machine, just open Windows registry, and you'll find how you should not name or group your parameters. Because, for example, here we have a lot of different stuff bunched together, and I don't even know what is MMCPL and why power CFG is named like that, and the input method is named with the space in that. So that's the way you should not do your configuration settings, and you should not. You should keep in mind that operations guys, they will work with this configuration, and they will have to support it. They will have to produce unique values for different environments, and if they can't understand what is going on, if these settings are not obvious, then they may make mistakes. Like with the code, if the code that you write is not readable, is not maintainable, then there's a risk that somebody who will change your code will actually make a mistake. So the configuration settings should be clean, the code should be clean and logical. Another important thing that developers usually, well, not usually, but sometimes they do not pay attention to is that applications should be monitorable. It should expose monitoring capabilities, monitoring data for operations. And these kind of things that usually are left over, and they're not enabled by default. And in this case, you have to, first of all, you have to know what kind of monitoring channels, what kind of monitoring protocols your operations guys are using. It could be JMX, it could be SNMP, it could be HTTP, and they can use different monitoring tools. And just ask them for the requirements, and just ask them what kind of protocols you want us to give you these data, and also expose not only technical metrics probably, but also like CPU, memory disk, and resource pools, database performance metrics, but also expose some business metrics, which may be important later on for production applications. Because if CPU is 100%, of course, you know pretty much what to do. Maybe just restart the server. But if the number of sales is going down, then it could be because of CPU, but it could be because of a different reason. So it's important to expose this information so it can be collected and put on the dashboard. And dashboards are quite a good way of having an overview of what's going on in the system. And as I mentioned in my story, yes, there were some dashboards for basic metrics, but there were no dashboards for vital metrics. And you basically just go into production in a blind way. You don't know what happened and what's happening with the application. So creating dashboards is visible for everybody, and it is easy to consume by anyone. Everybody understands dashboards. Another important aspect is that development should align early with production requirements. And as you see on this chart, like in traditional waterfall way of doing things, if development starts somewhere here, and at some point after that, we're starting testing, and then the number of issues, first of all, it grows, then it goes to a acceptable level, and then at some point it starts to go to production. And in an ideal situation, QA should find all the problems. But because integration with operations and integration with the real data happened late enough, the number of issues doesn't go down or doesn't go to a reasonable level, but it goes up, because the integration of operations was late enough. Another important aspect is that if you're doing, if you're writing code, you also have to, I think you have to also know how to write configuration of your operating system. And the thing is that there are already tools on the market like Puppet, Chef, Ansible, so they pretty much do the same thing. They have configuring infrastructure in the form of code. And because it's code, it will be very familiar to any kind of developer. And this is important also to build a bridge between what operations people do, usually manually, in fact, and what developers do. So you can actually talk with the help of code. You can produce definitions of how your software should be set up. And then in fact, you have a chance to find a common ground with them if you didn't have it before. Also, another important trick that could be used, that try to build a clone of production on your local machine. Same operating system, same components, same configuration, just running in a virtual machine on your laptop or some cloud provider. Because then you will be able to eliminate early enough all the issues you may have in production due to wrong configuration handling or wrong deployment or differences in component versions. And the best tool I know for that is Vagrant. It's basically a wrapper around VirtualBox where you can describe how your machine looks like, all the scripts, and what it needs this machine to be set up in a simple file, maybe a set of files. And then you can share that in the version control. And then you can make your operations guys actually check that and align it with you. So you have development environment and production environment as close as possible to each other. And speaking of that, there are kind of several similarity levels that I see here. And usually, it happens quite often that development environment is very scaled down version of let's say, QA environment, and production is even bigger. And the differences are so huge that the changes that you pour from development to production are having a lot of issues. The next level is that could be the differences are big, but not big enough. So I think that's where the most of organizations actually are. So, but the best thing is that you can actually try to bring the similarity level in terms of components and in terms of software installed almost to be the same. Another good thing to talk to system administrators from development point of view is that those guys, they actually use a lot of standard operating system packages. Just give one them. Just create one for them, because they know what is RPM if they work with Red Hat based systems. They know what is deb package if they work with Debian or Ubuntu, and they know what is MSI if they work with Windows. So, as part of development, make a package that is installable. This will save a lot of time. This will help administrators and developers find common ground. And it's not that hard to create those packages, in fact. They're pretty simple. And of course, all those things, as soon as you have a package, you can have a version of that, and you can deploy it to an artifact repository. And that makes things easily, it's easy to roll back changes if you have a version on a package. And deploy it or undeploy it or redeploy it. Another important aspect is that in my opinion, automation in form of code, in form of, let's say, Jenkins jobs or Gradle scripts or Puppet manifests, is more important than a huge architecture document that will become outdated like 2 weeks after that it was created. So it's more important to express everything that is happening inside the organization in form of the code and make it work on real service and make it automated than actually writing documentation about it. So it's automation over documentation. That's what I try to follow at least. I mean, of course, documentation is needed sometimes, but if you have automation in form of the code, it's in version control, it's versioned, then it's much better than having documentation. Outdated documentation. And obviously, yeah, you need to automate everything that's possible to, again, save time on different repeatable things, like build, release, deploy, task, backup, whatever. A few hints also for operations guys. I guess there are not many here, operations guys people, but still. Well, one thing is that get those damn developers to solve the problems that they provoke. Because usually it's not the problem with, it could be not the problem with the setup, but it's a lot of times it is a problem with architecture or with the application itself. And if operations guys are the ones who need to support the production system, they need to get someone who knows how to do it and then learn from that guy and do some postmortem analysis. Again, the same for repeating the same thing. Yeah, dashboards is important because you can make it visible for the whole team, both for developers and for operations and for management. You can expose your data, you can analyze your data, and probably it will be different dashboards, but it'll probably be the same data. Also, the logging on one of the previous presentations when Logstash was mentioned, and that's probably one of the best ways I know today to aggregate logs, because navigating through 50 different servers to find the problem in I don't know 200 different log files is a pain in the ass. So log aggregation, indexing, and backing up and rotation is quite important, and not in my experience, not all operations departments pay enough attention to that. Again, to build a bridge between what operations people do and how developers develop code, and is to learn, again, the provisioning software tools. And try to define, for operations guys, it's very important to them to try to define what they do, not in the form of Word document, but in the form of code. Because then it can be shared with developers easily. The developers can help there. And it's also, again, it gets all the benefits that the code has. It's versionable, it's auditable, it's trackable, and yeah, everybody has access to that. Keep everything should be in version control, and it should not be manual way of doing things like some of the systems still do, but it should be a propagation of the state from the version control to the actual environments. And as I already mentioned, that to close this loop between developers and operations, things that happen in production on ad hoc basis should be ported back to development. So developers should know that, okay, this setting doesn't work because of this and this. So just port it back to development environments and let the developers also be aware that this should be done. And another important aspect of operations that they should be ready for disasters. Disaster planning is well, you can't plan for disaster, but you can actually be prepared for that. So do backups, test your backups, and also do some capacity planning. And for that one, monitoring of your systems, collecting different kind of monitoring data about your systems is quite important because you can see the trends. And if you see the trend, you can plan capacity. Okay, just to close up, a few technologies to follow for virtualization on local machine. You can use VirtualBox, VMware Parallels, plus Vagrant. Well, it's a nice tool. For virtualization on operating system level, you can use Docker for remote virtualization and starting remote service. You can use various cloud offerings, and I guess most of you guys know about them, like AWS, VMware, Azure, Google Cloud, OpenStack. Infrastructure provisioning, I already mentioned them. It's like third time I'm mentioning these tools, and I think it's none of them is ideal, but most of them definitely will solve the problem better than if you try to write it yourself. For infrastructure monitoring and log collection, log aggregation, and dashboard creation, you can use these tools like Logstash for data collection, Graphite for monitoring sensor data collection, Kibana for creating login dashboards, Grafana for creating monitoring dashboards, and Dashing for creating any kind of dashboards. In fact, if you've seen the dashboard for this conference, it was created with the help of Dashing as well. There are several companies that are quite popular in DevOps community, and probably if you just search for DevOps, you will find a lot of slides and speeches from these companies like Spotify, Netflix, Etsy, Twitter, Amazon, Google, GitHub. And some books I would recommend to read in terms of getting your understanding of what DevOps is the Phoenix Project. It's not a technical book. It's a fictional book. Of course, it has some technical details in that, but it's very it's a story. Similar to the one that I told, well, not similar, much better, actually. And it's very easy to read. Of course, continuous delivery comes hand in hand with DevOps, and if you want to do continuous delivery and provision your infrastructure automatically, these books also give some good advices and some good principles. Another good book is Release It, again, about different techniques you can use for deploying production-ready software, also taking operations part into account. Another interesting book is about planning for disaster, and it's called Inviting Disaster. It's about different technical catastrophes that happened and why they happened and what could have been done to prevent them. So it's not directly related to IT, but it's related to technological kind of disaster handling. There are a lot of DevOps blogs, but these two I would like to mention maybe. The one is Enterprise DevOps, and another one is the blog from the guy who actually written the Phoenix project. So it's also quite interesting and quite contains a lot of information. Okay, I'm done. If you have any questions, I'm ready to answer.
I have a question.
Sure.
Jenkins is a good idea. So how do you version it? How do you keep under version control? These tools which are for, let's say, deployment, configuration.
Do you mean the Jenkins jobs or?
For example, Jenkins jobs. What's a good way to store them under version control?
Well, actually, there are several plugins for Jenkins for that. One is actually that stores the whole configuration of Jenkins in Subversion. Another one that stores versions of jobs in Jenkins itself. But I personally use a Gradle plugin that can recreate all the Jenkins jobs from XML templates in the version control. Did I answer your question? Anything else?
Actually, two small questions.
Sure.
The first one, the client base, is it native or abroad?
It's mostly abroad. I mostly work with Scandinavians and sometimes with Swiss companies.
Question, you mentioned internal culture is more important than tools. So how do you think, whose responsibility is to
Well, it's usually, the culture should come from top down, because usually it's harder to move it the other way, but it really depends on the organization, how it's set up. Because in my own experience, I tried in one big consulting company in Denmark, tried to move this DevOps culture to a bit higher level, and I met resistance. But I was well respected on operations among operations guys, among developers, but still it was not enough to move it forward on the company level. Anything else, guys? You didn't fall asleep, I hope. Okay, then thank you. Yeah, have a nice flight to DevOps space.